through this session we will learn disk input output. That is classification of input output statements of C language. That is input output statements are classified into three categories. That is, one is console IO, second one is disk IO, third one is port IO. Console mean a console unit consists of keyboard and monitor. So it is widely used in centralized computing. So two type of terminal is there. One is thumb terminal and another one is intelligent terminal. Intelligent terminal has own processing power, but in thumb terminal without processing power. With processing power is intelligent terminal, without processing power is thumb terminal. The thumb terminal is also called as console terminal. The console terminal, the data entry operator is also called as console operator. Console means keyboard and monitor. So in console IO, we get input from through keyboard and we will give output through monitor. So monitor is the output, keyboard is the input. Console IO we already discussed in previous session. The second one is disk IO or file input output. Disk input output, so it get input from disk. It give output to disk. The disk means a hard disk, pen drive. These are all the disk. If we want to get data, we want to store data for future use, we get input from keyboard. If we get input from keyboard, we write that inputs to hard disk as a file. This is disk output because our program store the data to hard disk, get the data from keyboard. So keyboard is a console input, but disk is the output. So disk output. If you want to access the stored data from hard disk, so this is disk input. If we access the data from stored file, this is disk input because that file is a input to the program. We display through monitor, or then we perform some calculation. So after the calculation we store that result into a new file. This is also possible. So disk input means we get data from file to the program. Disk output means we store data to the hard disk from the program. So this is disk input. So disk is input, the disk is output, but we can use a console input and a disk output. So disk input, we use console output. As per our requirement, we can use console IO or disk IO. Third one is port IO. Port IO, what are the port? That is parallel port, serial port, USB port, that is universal serial bus. If we want to connect the pen drive, that is a pen drive is a USB device. Then we put it into the USB port. So USB is a port. If we want to connect external monitor to our computer or our laptop, so we have one VGA or DVI port. By using this port, we can insert it. So different port is there. So if we want to give the output through the port, we are using port output. If we want to get the input signal from the port, that is port input. So if we want to connect any external devices to the computer, but we want to receive the data from the external device, we use port input. If we want to send the data to the external device, we use port output. This is port input and output. We can collect input from keyboard, then we send it to the port. So it is also possible. So we can use console IO, disk IO, port IO as per our requirement individually, or we can combinedly. We can use this kind of input outputs. In this session, we discuss about the disk IO, disk input function, and also called as file IO, disk IO or file IO. Disk IO consists of two types. One is high level and low level. Low level is closer to system. That is, it's like a machine language. So it's very close to system. So if we want to develop a system software, we can use low level disk IO function. But another type is high level language. It's closer to programmer. It is easy to learn. So this is the high level disk IO is suitable to write application program. In this chapter we learn about the high level disk IO. So high level also classified into two types: text, another one is binary. Text binary. So high level is classified into two types. One is text input output, so binary. The text also furtherly classified into two types: formatted, unformatted. Binary also furtherly categorized into two types: formatted, unformatted. So text has two types: formatted and unformatted. Binary also has two types: formatted and unformatted. What is the difference between formatted and unformatted? What is the difference between text and binary? Text, in text mode we can store character and string. We can access, store or retrieve character and string data types only. So text mode it is suitable to store other than numbers. So binary mode is suitable to store numeric related, that is graphic related, then numeric value related. We can use binary. So it has three difference between text and binary. So we will discuss in next. What is the difference between formatted and unformatted? Unformatted input access, unformatted IO access character and string only. It can access only character and string. It cannot access other than character and string. Formatted, it deal all data types. It access all data type. It may be a character or string, integer, float. So we can access all kind of data types, including character and string. But it has some difference. If we store character and string in formatted, it is differ with unformatted. So what are the function in formatted? Text mode formatted. So fscanf, file scan function. Already we learned scan function. So this for console input. Only scanf for console input, only printf for console output. Fscanf, file scan function. The short form of file scan function is fscanf. Then this is to get data from file, that is from disk. Fscanf function for input file. Fprintf, we can write data to the disk or to the file. By using fprintf we can write data to the file. Now unformatted is common for text and binary, but formatted is differ in text and binary. Text input is fscanf, output fprintf. In formatted, input is fread, fwrite function for input and output in formatted. Fscanf, fprintf for input output in formatted. But unformatted, it may be a text or binary. So input is fgetc. Input is fgetc for character, fputc for character output. If we want to get input, we can use fgetc. For output, fputc. So file get character, file put character. So fgetc, fputc to access character only. Fgets, fputs to access string. We can get string from file, that is fgets. We can write a string to file, that is fputs. So for character, unformatted character accessing, fgetc, fputc. We can also put getc, putc. Getc, putc is a equivalent name of macro name. We can also getc, putc. It is equivalent to fgetc. That is getc is equivalent to fgetc. Putc is equivalent to fputc. What is the difference between getc and fgetc? Getc is a function name. Getc is a macro name. Fgetc is a function name. Putc is a macro name. Fputc is a function name. But getc, fgetc, putc, fgetc are all equal. fgets fputs. Fgets for get string from file, fputs for write string to file. To open the file, first we want to open the file. At the time of opening the file, the file is always stored in hard disk, that is external storage device. The file are always stored in external storage device. If we want to open the file, it may be write or read. If we want to write a text to the file, or we want to read a text, read a data from file, it may be a write to the file or read from the file. We want to open. So what is the processing of open? All files are stored in hard disk. If we want to open a specific file, so it makes stream between RAM memory, that is main memory, and hard disk. So it's done by operating system at the request of compiler at the time of a program execution. So by using fopen function, we can open a file. After the opening a file, we can put the data to the file, or we can get the data from the file. So fopen is essential. So after complete the process, we must close the file. Otherwise, the stream is already at the time of file open, the stream is established between RAM memory and hard disk. So if we want to remove the stream, that is the connection between the RAM memory and hard disk, we use the fclose function. Without remove the stream, the connection between the hard disk and RAM, the computer processing is going on, the memory is unwantedly used by that file stream. So accidentally the data may be erased. So after the processing, we must close the file. So that the closing process remove the connection between, that is stream connection between hard disk and RAM memory. So this is a fclose function. So different kind of file opening mode is available. Totally 6 mode is there. The first mode is R. If we want to read data from file, we use R mode. That is in fopen function. This is the file mode. By using fopen function, we can open a file that can make a stream between hard disk and RAM memory. After making of stream, we can access the data from RAM memory. That stream can get data from file to RAM memory. Our program access data from RAM memory only. So if we want to open a file, that is we want to make the connection between the RAM and hard disk, that is data stream. If we want to make a data stream from hard disk to RAM, so we can use fopen function. Fopen function is required 2 arguments. If we want to call the fopen function, that fopen function is a predefined function. That function is included in stdio.h, standard input output header file. So fopen function, if we want to call the fopen function, we pass 2 arguments. The first argument is file name. That file name is already available in hard disk, or it will be newly created from hard disk. So this is a file name. If we like to read, so it is already available. If we want to write, it may be already available, or if it is not available, we will create it. So fopen, the first argument is a file name. The second argument is a file opening mode. The second one is a file opening mode. The first argument is a file name. So this is a file opening mode. We can give different as per our requirement. We can give the different file opening mode. That is R. R for read from a file. If we like to read a data from the file, we put R. If we want to write a data to the file, we give W. If we want to append, that is we want to append at the end of file, that is we want to write at the end of file, that is already file is existing. So that file has some records, some data. If we want to add new data at the end of file, we can put A, that is append mode. R plus, that is if we put plus after R or W A, it has different meaning. That is R plus is deal two kind of data. One is existing data, another one is new data. What is existing? Which one is new data? Which one is existing data? If already we created one file to store our address, that file name is address.txt. For instance, we assume we can already we created a file, that file name is address.txt. In address.txt we stored 5 addresses. In address.txt file we stored 5 addresses. So it already has some data. Now we open the file. We add another 2 records, that is another 2 address. That new 2 address, we add 2 address newly. That is called new data. Before open, already it has 5 records, that is 5 address. That 5 address is a existing data. After opening the file, we add 2 address. That 2 address is new data. So if we put R plus as file opening mode, read and modify existing. We can modify, we can read the existing data. As per our example, that is address.txt consists of 5 records already. Then we add new 2 address, that is new data. The 5 address is a existing data. We can modify that. That is in the second address. That is within the old data. It has 5 address. The second address is, we want to change in second address a pin code or name, anything, or phone number. We want to change, so we can change it by using R plus, because it change, that is modify. We can make alter the data, that is modify existing. So existing data we can read and modify it, but new data we only write it. We cannot able to read or modify by using R plus. But W plus, we read and write new data. W plus we can read and write new data. We cannot able to modify the new data. But existing, we can modify existing data. We can modify existing data, but we both read and write new data. In A plus, read and modify existing data. But new data we append it. We can append the data. So based on the functionality, we can use the file opening mode. File opening mode as per requirement. As per our requirement, we can use the file opening mode. Default mode. Default mode is text mode, because it consists of 2 types. One is text mode and another one is binary mode. If we want to open a file in text mode, just we put R or RT. So defaultly R, W, A are all text. Just we put R. This file is opening in text mode. We can read data from that file. We can also put RT here. So both are same. If we put R or RT, both are same. Defaultly it is a text mode. If we want to open a file in binary mode, we should put B after the mode letter. That is RB, WB, AB, RB plus WB plus AB plus. If we want to open a file, that is s.c is already binary file. If we want to open that, just we put s.c comma RB. If we want to write some data to that file, just we put WB. If we want to append some new data to that file, just we put A. If we want to modify or read the existing, but we want to write new, just we put R plus. So based on our requirement, we can use the file mode. Disk IO unformatted text. This is an example program for disk input unformatted. Unformatted, that is disk IO has 2 types. One is unformatted, another one is formatted. Unformatted deal only character and string. Formatted deal all data types. But unformatted also has 2 types. One is text mode and the next one is binary mode. Formatted is also has two types. One is text mode and another one is binary mode. In unformatted, it may be text mode or binary mode. The accessing statement, that is accessing function, are common for unformatted text or unformatted binary. Through this program, we copy a content of file to the new file. That is file copy program. This program is read all character from a file and write it into a new file. This is unformatted text. In unformatted text, we access character or string. In this program, we access character only. So we read character by character from a source file, then we write it into the new file, target file. So the source file, for example, this is a source file, that is s.c is a one of the file. That file consists of this program. It is a comma p, a equal to 10, b equal to 20. So this is a data of s.c. This program is stored in s.c file. Now we open this file as in read mode. Now we open this file in read mode. Then we read character by character. Then we open another file in write mode, t.c. This is a new file, target file. This is a new file. We write this file in write mode. We read a character from s.c. Then we write it to the t.c. So we read all characters, character by character. We read all datas. Then we write character by character into the t.c. So this is the program. That is main file *fs *ft. So file file. This is a macro for file structure variable. This is a macro for file structure variable. Using this macro, we can declare the file structure pointer variable. So file is a substitute name for file structure variable. The substitute name called as macro, that is file file. For readability, all macros are in capital letter. So this is also in capital letter file. So *fs *ft, this is user defined variable name. That is file pointer variable, file structure pointer variable. This is called file structure pointer variable. *fs *ft. So that fs and ft can capable to store address of file. So this is a file pointer variable. This size is 2 bytes. Fs size is 2 bytes. Ft size is 2 bytes. Because all type of the pointer of all type is in integer format. All type of variable address is in integer format. So we all pointer variable has 2 bytes only. All pointer variable size is 2 bytes. So fs is also a pointer variable. So fs is 2 bytes, ft is 2 bytes. Character sequence, it is a local variable. Here we open the file using fopen function. That function is an inbuilt function. That function is defined in stdio.h. fopen. So it has already we discussed it. That is, it has it requires 2 arguments. The first argument is file name. Second one is file opening mode. So s.c as input. The file name is s.c. This is a file name. s.c is a input. R is a file opening mode. So what is the meaning of R? We read a data from file. So that is R. By using fopen, we pass 2 arguments. One is file name, another one is file opening mode. If it is open the file from hard disk, that s.c is stored in hard disk. By using fopen s.c, R, that s.c is stored in same folder of this file, this program file. Already we stored this program in a folder. For example, in C drive tc/program. So we can also store this file in the same folder. Otherwise, we want to put the full path. Suppose this file is stored in D drive, d:\program. This is a folder name. That s.c is stored in D drive. in the program folder. But this program stored in C drive. So this program path is different from this file path. Then we must put file path, that is d:\s.c. We want to put double backslash, not single backslash. d:\s program s.c. Suppose that s.c file stored in the folder name of program in D drive. Here we put d:\s program s.c. Suppose that s.c file stored in the same folder of this program file. We can store this program in a file with the extension of .c. That s.c is also available in the same folder. Just simply we give the file name only. We do no need to put drive name and folder name also. So s.c or if the file is opened, if the file is exist, that file is successfully opened, then make a one stream from that file location, that is hard disk location, to main memory. That main memory address is returned to this area. If open, search the file. If the file is exist, it open in read mode. Then it make data stream between hard disk to RAM memory. That RAM memory has a specific address. That address is written here. Then that address is a file structure pointer address. That address is a file structure pointer address. That is the type. So here we declare fs. This is not a fp. It's a typo error. There is fs source file, target file, fs. In fs equal to, so it written file structure pointer variable. Fp is also a file structure pointer. It written file structure address. That address is assigned to fp. So now fp has a address of RAM memory area. This is a stream. This is a stream of s.c. Suppose any file opening problem. We cannot open the file. The file is not available. The path is wrong path, or due to some networking security, the file cannot be opened. Any one problem. It may be any one of the problem. So the file opening is failure. fopen function return null, null. Null is also a macro. This is because we are putting a capital letter. Null is also a inbuilt macro. What is the meaning of null? No address, no value, just we represent 0. No address, we put null. We cannot able to put 0 for no address, because 0 is also a kind of address. So address start with 0. So we cannot able to put 0 for no address. No value, we use 0. No address, already one macro is there, that is null. It is a inbuilt one. So null. That null pointer is returned to fp. If file opening is any error, give any error, it will not successfully open the file. So it return null. That null is assigned to fp. If fp equal to null, the condition is true. The file opening source file cannot open. Terminate the program. Because without the file opening, we cannot do any work. So it check the file is open or not. fp has null, the file opening error. So failure, file opening failure. So it gives some message, source file cannot open. The exit function it will terminate the program. If the s.c file has opened, that address is written and stored it into the fp. That address is equal to null, the condition is false. Then it's open another file that it is in write mode. That file name is t.c. As per our example, s.c is already available. t.c is a new file. So that new file in write mode. If already t.c is available, here we put write mode. So at the time of file opening, the existing file is overwritten. So it create new file. So if any data is available in old file, it is overwritten, it's create new one, the already available data, that is existent data, is erased. Then this file is open in write mode, so that file open in a hard disk, so it makes stream between hard disk and RAM memory. That RAM memory address is returned here, that address is stored in FT, because FT is also a file structure point variable, so it can store address. If any file opening error, so it return null. The condition is true, the display target file cannot open. Then F close of Fs, because this condition is false, then only it come and open this file. This condition is false, the file successfully opened. So after that, the files successfully open, after the successful open, it will execute this statement. But this statement is written null, it cannot open the file. Just we display the message, error message, target file cannot open. We want to close the stream between the hard disk and RAM memory, because already it makes some stream between s.c file to RAM memory. So we want to close the stream by using F close of Fs. Here we put Fs. This is a printing mistake. So it is Fs. This is also Fs. So we F close of Fs. Then we exit the program. Without close the file, if we exit the program, the content may be destroyed. S.c content may be, the file s.c already has some content, it may be destroyed. So for the security of file, we must close that. F close exit. If the condition is fail, that is it is success, this one is success, then only it come to this statement, this file is also success, the condition is false, come to while loop. So that is a hard loop, it always true. Then ch equal to getc of Fs, we get a character getc. Getc is here, we can put getc or fgetc, both are same, fgetc or getc. The getc console IO, in console IO we have studied, that is getche, getchar, getch, getchar. This is console input for character. Here we put getc, not getch or che or getchar. Here getc. Getc is a macro, that is it is a substitute name for fgetc. We can put fgetc or getc of Fs. This is a file structure pointer variable, that is a Fs. This is a typing error. This is Fs equal to 1. It has address of that file, because at the time of execution this statement, it open a file from hard disk, then it makes stream, it stored in a RAM memory, it allocates some RAM memory, it makes a stream between RAM memory and hard disk, that address is stored in Fs. This is a typing error Fs. Here we see ch equal to getc of Fs, it get one character from that file. First it read one character, and that character is assigned to ch. Ch is a local variable, that is it can store one character. So it read one character and stored in ch. In our program, that is in our file, m is the first character, because s.c, this is s.c. So m, so it read m, the character m, and assigned to ch. Then if ch equal to eof, so what is the value of ch? That is m. M equal to eof. Eof is a end of, it is a short form of end of file. This is also a macro name. It is a inbuilt macro name. So this is include the ASCII value 26. ASCII value 26 is a last character of a file. If you in a text file, last character of text file. If we create a text file, we enter some data. So it internally store one ASCII value 26 at the end of the file. So that character is a end of file marking in text mode only. Binary mode is differ with text mode. We will discuss about the difference between binary mode and text in next slides. So this is a content, the EOF is a end of file marking. The first time it get M only. If read all thing, that is closing brace, it is a hidden character, that is equivalent to ASCII value 26. That's written. EOF is a equivalent of ASCII value 26, that are equal. So at the time of end of this file, only it is true. The first time it is M equal to A of false. Else mean put C of CH comma FT, put C. Already we discussed put CH, put char. Put CH, put char. This is a output function in console IO. This is a output function of console IO. That is put CH, put char. But this one is put C. Put C. We can also write F put C. Both are same. Put C of CH comma FT. FT is a target file name, that is t.c. The file name t.c, it makes stream between RAM memory and hard disk. That RAM address is stored in FT. So that CH, what is the value of CH? M. That M is write into FT using that stream. So it stored it to t.c. That is available in hard disk. So that M is transferred to FT. Then the loop continue. The kind always true. CH equal to getc of FS. So then we use getc of FS. So it get another character. Already we get M. So the second getc, it get another character. The next character A. The condition is false. It write A to FT. It's continue I, N, opening parenthesis, closing parenthesis, new line mark, opening brace, closing brace. So it read to character by character. The condition is false, is right. So it write a semicolon, closing brace. The main function closing, it read closing brace. Closing brace equal to EOF, false. So it put that closing brace in FT. That is t.c. So it continue the loop. It get another character. After the closing brace of main function, it internally stored one file termination character, that is end of file marking character, ASCII value 26. It's read that ASCII value 26, then stored it into CH. Now CH equal to EOF, ASCII value 26 is equivalent to EOF. So EOF is a substitute name for ASCII value 26. The condition is true. The break, it break the while loop. It come out the while loop. Then display information to the user, file copied. Then we close FS FT. We want to close the source file and the target file. Then only it remove the stream between hard disk and RAM memory. So this remove the stream between S.C to RAM memory. This remove the stream between T.C to RAM memory. That S.C, T.C are stored in hard disk. So after the closing of two files, we terminate the main function. So to display only file copied. If you want to know the content of t.c, just we open using our editor. It may be a C compiler or notepad, anything. By using any one of the editor, just we open t.c. So it has the same data of s.c. So it copied all character to t.c. So this is the file copy program by using text character. This is if we want to change as binary, because unformatted, that is getc, putc. Its equivalent is f getc, f putc for character.